Hello guys, today we'll be dealing with falling edge output, which is a one-shot falling. In other PLCs it's an OSR, and the opposite of this one is a one-shot rising, which is a rising edge output. So the mnemonic for this is a PLF. So I'm going to explain this function. This function, it really works especially when you are being cornered by a program, when you're running out of a syntax, and how you can come out of a situation which is becoming a bit complicated. You can use this falling edge. It's like it's a lifesaver, if I may say it that way. So this is a normally open run. When I switch this one on, this one must go on. So I'm just gonna start simulating now, and then we see. So if I do this, this is a general program. It's not in run. You can see here it's on stop. It's in stop, so I must press run. If you do this, your logic goes on. If you do this, your logic goes off. If you do this, your logic goes on. If you do this, your logic goes off. So this is a simple switch, right? But when you're now using one shot falling, you see, when you're now using one shot falling, we are actually saying, let me go back to the diagram. I like teaching with the manual because it gives someone the bottom understanding of how it works. So how it works now is like, if you look at this timing diagram, whenever you press your input, my input is M0, right? Whenever you press your input, ignore the numbering, the tag, the X0 is different from my main program, okay? Whenever you press X0, which is your input here, whenever you press X0, X0 will go on, right? And then it will go off. It's like it's a push button. A push button, you press in and then you release. So whenever you press a push button, when you release now, the moment you release, that's what I call a falling edge. Because in terms of logic, gets a high is 1. So means when you press, you are going on. And then when you're switching off, that's when you're releasing. So when you're releasing now, the moment you release or the moment you switch off, the pulse flag, this PLF, it gives a positive output. So it means when X switches off, this thing gives you a rising edge. It gives you a rising edge. It switches on. What am I saying here? You might not understand, but I'm going to do it with the program. So what this means is, I'm just going to put a program here quickly. I'll say load Y0. There's an M there. Load Y0, and then out Y2. Okay, right. And then I say or Y2. Okay, let me just say LDI M1. Okay, right. I'm gonna download this program here. Download this program. Okay, so generally what we are saying, when you see this thing on like that, this thing goes on, which is normal and is very normal in terms of conventional circuit that you understand. When I switch this thing off, this one goes off, and this one latches because it's a direct online circuit. It's a latch circuit. So when you switch this one off, and then your circuit goes off. Okay, so what I'm gonna do now, I'm gonna put a falling edge now. A falling edge in Delta PLC, you get it on a button like this, and then you double click, and then you press falling edge trigger like that. Right, so you're gonna see a change now. Remember last time when I switched on my Y, everything went on, but now it's a different case now. It's a different case now, because when I'm switching off, that's when the system must go on. Okay, right now. So When you switch on Y0, M0 is on, Y0 is on. We go back to the diagram now. When you switch on, this is our M0, right? It's like our Y0 as well is on, but nothing is gonna switch on our latching circuit. It only energizes on the falling. So when I'm switching off now, this thing gives you a positive pulse. It's like there's a, so when I switch off this circuit, it means this thing, it gives you a positive. It's like there's a push button, someone pressed here. So I'm gonna do this. When I set off, that's when Y2 goes on. So it's like when I'm switching off the falling edge, it gives you a positive pulse to switch on. It's like there's a pulse, someone pressed, you see. So that's how it works. I'm going to do it another example, which is a bit different again, because this is a bit complicated, maybe to some people. And then I say X1, X, which is an input in Delta PLC. And then I'm going to download this quickly. If you have questions, just comment, I'll assist you. Right, we have another option here. Remember, okay, sorry, I made a mistake. I must put another one to really compare. I say copy, then I say paste, then I delete this, then I leave this like this. X1 is X1, X2, I change address here to Y3. So we have two similar circuits, but they are different. One has got a rising edge, another one has got a falling edge. One is just a normal open, the other one has got a falling edge. So I'm gonna start simulating now. This register is the same, so whenever I switch on an X1, it affects both of these. So when I force on this, right, I force on, remember this, you see this one, it switches on there and there. This one, it switches on there, both just a straightforward normal open examine, a normal open, it goes on, right? When I switch off now, this one, that's when it goes on. So it means when you've got a motor that is running, the moment you switch off the motor, you want to start another motor, you see, you use a falling edge. So let's say another motor is switching off now, that's when this one goes on now, you see. So it only responds when something is switching off. When something is switching off, it switches on something, it gives you a positive edge, you see. Okay, I have an example here. That I have because I really want people to understand better. Okay. Okay. Right. This is a question here. When start push button is pressed, motor 1 runs. Motor 2 remains off. When stop push button is pressed, motor 1 switches off instantly. Motor 2 starts running. When stop push button is pressed, motor 2 stops. Note the buttons are push buttons, right? So I'm gonna write the program. It's actually similar to what we have here. It's actually, I have written the answer effect because I knew I was gonna ask a similar question. But what this means is like, okay, let me just run this quickly. Let me just try this quickly. Okay, delete. Okay, motor 1, address Y0. Motor 2. Start X0. Stop. Okay. stop 2, and then start 2. Okay, it's done. We've already done a circuit like this. Okay. Oh shit. That's why I like texting once. I like typing. This thing, it gives me a hard time. Okay, thank you. Finally. Okay, I'm just gonna copy this. Then I paste this, and then start 2, stop 2, motor 2, motor 2, stop motor 1, start motor 1. Okay, right. When the pressing of start, motor 1 runs, and then when motor runs, switches off, motor 2 starts. So you use a falling edge. When motor 2 switches off, so we don't need a start 2 because we are not starting this motor 2. It's being started by the switching off of motor 1. So when motor 2 switches off, you put a falling edge. This falling edge is gonna trigger. It's like someone has pressed here. It's gonna trigger, and then motor 2 switches on, right? So I'll put here motor 1, like that. So guys, if this is very helpful to you and you are benefiting something and you are learning something new, or I'm clarifying something that you didn't understand, just please appreciate by clicking the subscribe button. I really appreciate. Thank you in advance. Thank you so much. Don't forget to like. If you've got any question, or if you want me to do a certain explanation on another area, just highlight in the comment section. I'll do a video specifically for that. Okay, all right, so we are ready now. So if someone presses start, force on, motor 1 is running. Remember, it's a push button, so when you press start, you must switch off. Okay, right. And then when it's a push button, you press, you release. So that's why I force on and I force off. And then on a stop button now, you see someone is gonna force on, force off. The moment they force on, the moment someone presses, when this one switches off, this one gives you a positive edge, and then it energizes motor 2. So this is the falling edge. The one shot falling. It's called one shot falling, but it's actually gives you a start. It actually gives you a positive signal when it's falling, right? So it's actually a simpler way to solve your problems. Let's say they're saying when something stops, something must start. You use this. It's very simple, especially and one thing that I must clarify now, this instruction, you cannot see it by doing this, right? I was using a hold-in because I wanted you to see, right? I'm going to download this program now. It doesn't have a hold-in because it's one shot. It only gives you a rising for one scan time. Take note. So you must use it with a set or a latch circuit. You must use it with a latch or a set circuit. Okay, this is how I'm gonna do it. I'm about to finish my tutorial. It's almost reaching 15 minutes now. Okay, so now when you switch on now, force on, right? What's going on? Okay, this one was supposed to be off. Okay, when you switch on, this one is running, but the moment the switch is off here, you see nothing happened here. Why? This thing is already switched on. The motor 2 is already switched on and switched off, but for one scan time. You can't actually see one scan time with your eyes because it's a millisecond. So you can see here on X0 PLF M0, it becomes on and off there and there for one scan time. So the only way to catch this one scan time is to use a latch circuit like the one I used earlier, or you can use a set. You see, if you change this now, remember this time it didn't switch off. If you change this into a set, you can actually catch that one scan time, because now it switches off and switches on and off, but you don't see it because it's only a pause. So let me do it this way. I want you to see the difference. Now you're gonna actually see the set on, because a set can actually detect one pause. There it becomes on. You don't switch it off until you reset it. I'm going to do a lesson on the sets as well. So very sorry to introduce something new in the middle of the lesson. This one I always forgot to switch it on. Is it on or off? Switch it off, something like that. Yeah, so that it always normally goes. So when I press force on now, the thing goes on. When I switch it off, the stop button. So here, when I switch off now, so you actually force by switching on. When I switch on now, the set goes on. The set goes on because it can actually catch a pulse, but a normal coil cannot catch a pulse. So you see, and the only way also to reset this is to use a reset. Oh, I'm teaching you so much now. This is just now a bonus to those who were patient to see the end of the lesson. This is just a bonus, but I've already explained how a falling edge works. So this is the reset. You reset by pointing with the address. You reset by point. This is not part of the lesson now. This is just a bonus ball. Like a lotto. This is just a bonus ball. You see, so this is just a bonus ball. I'm just gonna say M0, right? This is how you reset, because you're gonna say no, we have switched it on, but we can't switch it off. This guy Yang does. So if this is helpful to you, click the subscribe button. This is the falling edge. This is the falling edge, okay? Okay. Switch on, right? Oh, I always forget. Remind me. So once I press start, force on, it's running. Force off, it's a push button. That's why I do this twice. Because you push in, you release. And then here now, I'll force off. When I force off, if you remember, I force on, this one switches off, and then this one is set, right? If this one is set, the only way to reset is you must put a reset button with the same address. So if I switch this M on, there it resets now, you see. So thank you guys. Thank you for subscribing. Thank you for watching. If you've benefited something, click on the subscribe button. If you want me to do something, just comment. Thank you.